Okay, good afternoon, everyone. So today I'll be going through practice exercise 10.3. So let's start with question 7. So A, B, C, and C, D, E are straight lines and angle DAE is 45. So written here 45 degrees. Then angle ABE and ABE is 50 over here and BDC is 66. So part A, find angle AED. So this angle over here. All right, so for this, right, we can find out what is angle uh EDA first. So angle EDA is this one, right? It's actually equals to angle EBA, which is 50 degrees. So the angle property here is uh angles in the same segment. Okay, so this is 50 degrees. All right, then angle AED will be equals to 180 degrees minus 50 degrees minus 45 degrees. Right, this will give us 130 minus 45, so 85 degrees. Okay, so this is sum of angles in a triangle. All right, so 85 degrees. Now let's move on to part B. So part B, they want us to find angle BCD. So over here lah. So I want to find this angle. All right. So angle EBD, right, is equals to angle EAB. So EBD and EAD, right? Same is equals to 45 degrees, and then angles in the same segment. Okay, so here is 45. Right, so what is angle BCD? So angle BCD is equals to uh actually we can find I mean we can do it straight away lah, but okay lah, let's just do a little bit longer. So we find angle DBC first. So angle DBC. Angle DBC equals to 180 degrees minus 55 degree. Okay, sorry, 50 degrees. 50 degrees and then minus 45 degrees, right? This will be 85 degrees. Okay, so DBC here is 85 degrees. Yeah, and this is adjacent and uh, adjacent angles. Adjacent angles on a straight line. Okay, yeah. So after that, so angle BCD is equals to 180 degrees minus 66 degrees minus 85 degrees. So 29 degrees. Okay, so this is sum of angles in a triangle. All right, and then yes, so for part A is 85 degrees. Okay, and then for part B is 29 degrees. Okay, yes, and so this is it for question 7.
Okay, hi everyone. So let's go through question 9 together. So question 9 here. So in the diagram, BD is the diameter, right, of the circle, and AC, right, AC and BD intersects at E. Okay, they also tell us AB over here is equals to AC. So that means triangle ABC is an isosceles triangle lah. Okay, and then lastly, angle BAC is 52 degrees over here. So part A, find angle BDC. So angle BDC is this angle over here. All right. So how do we find this angle? So actually angle ABD. Okay. So part one over here. Okay. So angle BDC, right, is actually equals to angle BAC, right, which is 52 degrees. So the reason being is because this is angles in the same segment. Okay, so that's why this angle is 52 degrees over here. So this is 52 degrees. Yeah. So angle BDC and angle BAC is equal. All right. So this is it for part one. So now let's move on to part two. So part two, I'm going to write it in black. Okay. So part two, angle ACB. So where's angle ACB is over here. All right. Yeah. So as you can tell, right, just like I mentioned, triangle ABC is an isosceles triangle because AB, right, AB is equals to AC. So therefore, we can find angle ACB, right? So angle ACB is equals to 180 degrees minus 52 degrees divided by 2. All right, this is a base angle of an isosceles triangle, right? So let me just do a quick calculation and then the answer will be 64 degrees. Okay, so base angle of an isosceles triangle. All right. Okay, guys, let's do part three together. So part three, right, gonna do change it to orange lah. So part three, right, we want to find angle ABD, right? So ABD is over here. So this angle over here, right? Okay, so first thing first, let's try to find out lah. So first thing, we need to find out what is angle DAC first. So the angle over here, DAC. Okay, so angle DAC is equals to 90 degrees minus 52 degrees, right? And it's equals to 38 degrees. So the reason is because right angle in a semicircle equals to 90 degrees. All right, how come? Because DEB or rather BD here is the diameter of the circle. Okay, so this angle here is actually 38 degrees. Okay, so that means we also can say that this angle here will be 38 degrees. Okay, how come? So look closely. DAC, all right, and DBC, they are equal because angles in the same segment. So angle DAC, or rather angle, angle DBC equals to angle DAC equals to 38 degrees. Okay, so angles in the same segment. Okay, so this is 38 degrees. And lastly, we can find out what is angle ABD already. So angle ABD will just be equals to, because ABD is over, okay, because ABC, right, just now we found, because it's a base angle of a triangle, so ABC is 64. Okay, so we take 64 degrees minus 38 degrees. All right, and then this will give us 26 degrees. Okay. Yeah. All right, so this is it for the part three. Okay, so let's move on to part D in pink. Okay, so show that triangle. Okay, let me write this first. So this is 26. Okay, show that triangle ABE, this triangle, and DCE, oh, are similar. Okay, can. So first thing first, let's find out. Okay, so we can because it's similar, right? So we can actually do A test lah. So let's find out what is the first A. Okay, so first A very simple, right? Because they say that AC and BD intersect at E, right? So that means we can say that angle AEB, right, is equals to angle DEC. Okay, because why? Vertically opposite angle. Okay, so that's the first A lah, so called the first A. Okay, the second A, it will be angle BAE, right? BAE equals to angle CDE, right? CDE equals to 52 degrees, right? As found in part one lah, right? So angles in the same segment. Okay, so therefore, right, triangle ABE and triangle DCE are similar using AA similarity test. All right, yes, so this is it for question 9. Okay, let's go through question 11 together. So let me use black. Okay, so in the diagram, A, B, C, D, right? A, B, C, D are 4 points on a circle. So it means that they are on the circumference of the circle lah. Right? With center O. So O is the center. Okay, and then it's also mentioned that AB is parallel to OC, as you can see from this two arrow. AB parallel to OC, and then angle OAB is 42 degrees here. Okay, so part A, find angle ADC. So where's angle ADC? This angle over here. Okay, so first thing first, I can find out what is angle AOC. So angle part A, so angle AOC equals to 180 degrees minus 42 degrees, and that will give me 138 degrees. Okay, how did I do this, right? So this is interior angle, right? Interior angle AB parallel to OC. So I'm using this parallel property to find out this is 138. Okay, 138 degrees. And then as you can tell, so because angle AOC is related to angle ADC, how? Right? Angles at the center equals to two angles at circumference. Okay, so look, it originates from A and C, right? So ADC, AOC. So that means I can say that angle ADC is equals to 138 degrees, right? Divided by 2. Okay, so this will give me a hold on a minute. 69 degrees. Yep. So 69 degrees, and then this is angle at center equals to 2 angle at circumference. So it's very important, right, for you to write out the angle property, because marks is allocated for this lah. And if you don't, your marks will be removed lah. Okay, so yes, this is 69 degrees. Okay, then next part B, find angle ABC. So ABC is over here. So very simple, because ABCD is a cyclic quadrilateral, right? So that means angle ABC and angle ADC is related. So how are they related? So they are related by angles at the opposite segment. Okay, angles at the opposite segment. Yeah. So angle ABC equals to 180 degrees minus 69 degrees. All right, and then this will give you 111 degrees. Okay, so angles in the opposite segment. Okay, so that's for part B. All right, let's move on to part C. So angle, oh, okay, let me label this. So this is 111 degrees. So next one, angle OCB. So this is angle OCB lah, this blue angle over here. All right, so as you can tell, this is a quadrilateral. AOCB is a quadrilateral, right? So sum of angles in a quadrilateral, or rather sum of interior angles in a quadrilateral adds up to be 360. So angle OCB will be equals to 360 degrees minus 42 degrees minus 138 degrees minus 111 degrees. And that will give me, let me calculate, 69 degrees. Yep. Okay, so sum of angles in a quadrilateral. All right, okay, so yes, this is it for question 11. Okay, let's look at question 12 together. So O is the center of the circle, right? And then AB, right, is equals to BC. Okay, so if you draw a straight line connecting A and C, right, you will have an isosceles triangle lah. Okay, probably you need to use it later. And then angle ODA, this one's 46 degrees, and CDE is 120 degrees. So part A, find angle ABC. So angle ABC is over here. right? This is angle ABC. So how do we find angle ABC? So what I can tell is I can see that ABCD, right, is a cyclic quadrilateral. So in a way, ABC, right, and ADC will add up to be 180 degrees, right? Angles in the opposite segment. So let's find out what is angle CDO first. So angle CDO, right, is actually equals to 180 degrees minus 120 degrees minus 46 degrees. And this will be 60 minus 46, so 14 degrees. All right, so this is adjacent angle on a straight line. Okay, so this is 14 degrees over here, right? So then now we can find out what is angle ABC already. So angle ABC is equals to 180 degrees minus 46 degrees minus 14 degrees. All right, and that will give me 120 degrees. Okay, so 120 degrees. So this is angles in the opposite segment. Okay, so that's it for part A. Right, oh no, okay, part A. Right, so now let's move on to part B. So part B says find angle AOD. Okay, so angle AOD over here. All right, so as you can tell, right, OA and OD is actually the radius of the circle. So actually this and this is same length, which also makes it an isosceles triangle. So angle AOD, because it's an isosceles triangle, so I just take 180 degrees minus the two base angle. Okay, and that will give me 88 degrees. Okay, so this is uh some, okay, or rather we are using sum of angles in a triangle lah, right? Just that we know that this is an isosceles triangle, so we can take 180, right, degrees, 180 degrees to minus away the two base angle, which is 46 degrees each. Okay, let's move on to part C. Okay, so part C, they want us to find angle, or let me label this first. ABC was 120, CDO is 14 over here, and this is 88. Okay, so BCD, right, in part C. So BCD over here. Okay, can. Let's take a look. Uh, okay, what I'll do is I'll draw a straight line connecting A and C lah. So like that, right? So we are going to do a two part. So we're going to find angle BCA first, and then we're going to find angle ACD, right? And then add them both together. So angle BA, no, BCA, sorry. BCA equals to 180 degrees minus 120 degrees divided by 2, right? So this is 30 degrees, and this is base angle, right? Base angle of an isosceles triangle. Okay, so this is 30 degrees over here, this one. Okay, so next I want to find out what is angle ACD. So angle ACD is actually connected to angle AOD. How come? Because angles angles at center equals to two angles at circumference. All right, so that means angle ACD equals to 88 degrees divided by 2, which is 44 degrees, right? So angle at center equals to 2 times angle at circumference. Okay, so this is 44 degrees. Then lastly, angle BCD will be equals to 44 degrees plus 30 degrees, and that will give us 74 degrees. Okay, and yes, this is it for question 12. Okay, let's take a look at question 14, right? So the diagram below shows, I mean on top actually, shows a circle where AD, right, is parallel to BC, and angle ABC is 112, angle BAC is 40 degrees. So explain why AD is not, right, is not a diameter of the circle. So in order for us to explain, right, we must actually try to find out what is angle ACD, right? This angle. So the moment, right, it is not 90 degrees means AD is not diameter. Okay, this is something we must establish. How come? Because we learned that, right, if it's a AD is a diameter, right, it will be right angle. Oh, crap. Right angle in a semicircle. Okay, so in order not to fulfill this criteria, right, this mustn't cannot be 90 degrees, right? And then it will go to show that AD is not a diameter. Okay, so first thing first, let's find out, right, how to find angle ACB. So this angle over here, right, ACB, this angle over here, right? So angle ACB is equals to 180 degrees minus 40 degrees minus 112 degrees. Okay, so let's do a quick one. 28 degrees. Okay, the angle property here is sum of angles in a triangle, right? So this is 28 degrees. Okay, so next step, we can find out actually what is DAC. How come? Because BC is parallel to AD. So we are going to use alternate angle. All right, so angle DAC is equals to angle ACB, which is equals to 28 degrees. All right, alternate angle, and then AD parallel to BC. So you only can use this when there's a parallel side lah, in short. So this is 28 degrees. Okay, the next one, we can find out what is angle ADC over here. So how? Look at ABCD. All right, it's a cyclic quadrilateral in a triangle, I mean in a circle obviously, right? So we can find out angle ADC. How? Because angle ADC and angle ABC will add up to be 180 degrees. Angles in the opposite segment. All right, so how to find angle ADC? So angle ADC equals to 180 degrees minus our angle ABC lah, which is the same as 180 degrees minus 112 degrees, which will give us 68 degrees. So this is 68 degrees. Okay, so lastly, now we can find out what is angle ACD already. Angle ACD is equals to 180 degrees minus 68 degrees minus 28 degrees. Okay, let's calculate. And that will give us 84 degrees. All right. Yeah, so as you can tell, because angle ACD is not 90, aka is only 84 degrees, right? AD is not a diameter of the circle. So I will say since angle ACD is not equals to 90 degrees, right? AD is not a diameter of the circle. So the angle property here we are using is right angle in a semicircle is equals to 90 degrees. Because since it is not equals to 90 degrees, it will not be a semicircle, right? And therefore, AD is not a diameter, right? Okay, yes. So this is the last question for exercise 10.3. And yes, this is question 14.